It's a far cry from the Hollywood production of demolition.
5, 4, 3, 2, 1.
No cameras perched at every angle to catch a glimpse of their work. But without these unsung heroes, building demolition would not be possible. It takes about 3 times longer to deactivate a building than it does to demolish it. The nearly 400,000 square foot K-27 building will take 36 months to deactivate. Demolition in just 12 months. No heavy equipment and dynamite for this job, but precision, perseverance, and patience. Building K-27 was constructed in 1945 as part of the nation's World War II defense strategy, the Manhattan Project. The plant enriched uranium using a gaseous diffusion process, supporting weapons production and other security strategies until 1964. Crews will cover more than 1 million square feet of floor space to ready K-27 for demolition.
One of the first goals that we do when we hit a building for D&D is we look for cold and dark.
The task begins by removing all hazardous energy sources. Utilities are isolated, mains are cut, and a thorough investigation is conducted to ensure that every conduit or pipe that goes into or out of the facility is suspended.
One of the main drivers in the amount of time it takes for deactivation is how they shut the building down. K-27 as a whole was shut down properly.
Map and measure marks the beginning of the characterization phase of deactivation. At this point, crews use equipment like high-resolution gamma spectroscopy to determine what and how much uranium residue is left behind in piping, components, and equipment.
This is an important part of characterization because when the demo is done, you've got a pile of trash. Now, what are you going to do with it? Where's it going to go? You have to characterize it so it goes to the right place and meets all the requirements for disposals. So I look at the equipment, I identify the process systems, the non-process systems. We mark foot by foot each of the pipes. Each component has a unique identifier. So in effect, we're producing an inventory of all the piping and components of all the process gas systems.
In K-27, approximately 112,000 linear feet of piping will require identification and marking. The process known as vent, purge, drain, and inspect is another crucial aspect of K-27 deactivation. Workers use a moist air purge to stabilize and remove residual liquids or gases left behind in process lines.
We start with the venting, which is a controlled release of whatever pressure might be in the system. And then from there we'll do the purge of the system, which will hook up a C1000 HEPA unit and then pull negative pressure on the system to release any sort of gas that might be contaminated.
Workers use borescopes to visually inspect the interior of piping and other components.
You're watching a TV monitor and can see all the stuff that's still inside the pipe and also what we're going to be dealing with on a day-to-day basis until we get that pipe out of there.
We're also looking for deposits inside the pipe, those stalactites and stalagmite type stuff.
If workers discover uranium deposits that exceed waste disposal limits, the impacted equipment must be removed. After removal of all highly contaminated material, an expanding foam is injected into the process pipes.
The foam expands at a certain rate and to fill a certain space. Then we have a set time that we have to shoot it, otherwise it will end up with too much or not enough.
The foam eliminates cavities when the pipe is buried, and it also suspends any contaminants remaining in the pipe. Based on characterization results, approximately 20% of K-27's components must be removed and shipped off-site prior to demolition.
During deact, we're going to have about 120 converters. We'll have approximately 240 compressor volutes that will be removed prior to demo.
We cut the cell houses out to be able to get the compressors out. They use a saw, which, when they cut out with a saw, they got a lot of sharp edges. The metal that we cut loose, they'll stick it in a hopper, and then we'll take it around the building. We throw them into the vault.
My crew will go in with a saw and remove the pipe, and the iron workers will rig it and lower it into a box. The pipe will be removed so that they can get the converters and the compressors out of the cell houses.
A lot of people think about piping might be 1 or 2 inches in diameter, but some of this stuff can be as big as 20 or 30 inches in diameter and weigh as much as 100 pounds per foot.
The remaining equipment meets waste disposal criteria and is demolished with the building structure. Before the crews enter the building to start any work, they attend a Plan of the Day meeting, or POD.
First thing that we do in the mornings is we get together for the plan of the day. That tells you what your hazards are, and it also tells you what your job scope is.
By the time you get done with that meeting, you can walk in that building and go straight to work.
Next, crews suit up in the appropriate personal protection equipment, or PPE, based on the hazards they will encounter that day.
We have different types of protective clothing. Some are lighter weight, some are heavier weight, some are water impermeable, so the contamination doesn't soak through to a person's inner clothing.
When you come out of the building is getting all the clothes, the PPE off that you have on. And there's a process that you have to go through in order to do that safely so you don't have any contamination issues.
Each day, crews face high-risk, high-hazard conditions, exposed to radiological and chemical contaminants, extreme temperatures, and deteriorating infrastructure. Therefore, worker safety becomes the most rigorous task performed.
Our primary hazards, really, of course we have the process gas equipment, but many of the hazards we have are typical for any construction site.
Radiological control technicians help crews understand the radiological hazards of the work environment.
Our RADCON group, they go ahead of us and would survey the work area to give us a baseline of where we're at for contamination.
The RADCON folks want to know what the workers are getting into before they get into it.
During the job, when they're always using their hands, so we have to frequently check their hands for contamination.
In K-27, uranium-235 and technetium-99 pose the greatest radiological risk. PCBs, mercury, and asbestos represent the greatest chemical hazards.
We're constantly monitoring for asbestos if asbestos work is being done. We want to make sure they're wetting enough so there's not asbestos fibers in the air, but we have air samples that are being pulled and checked to make sure that they're not being exposed. If there is an exposure, they're protected from it.
Poor lighting and structural decay create more threats. Add extreme temperatures and the stakes get higher.
The summer months are what's really rough, is the heat, and then all your body's natural mechanisms to control your temperature are null and void by your dress out because you have no air hitting your skin.
I guess the best way to describe it would be kind of like cooking something in the oven, except you're in the oven sometimes, and it's warm.
Anybody that goes into the building, we're kind of covering just on a heat aspect. We want to make sure nobody's going to fall out from heat stress. Depending on what they're doing makes whether that's a larger concern or a smaller concern.
The one thing that we watch out for is sweating through. If you sweat through, the water, it sort of like draws the contamination through the material and you can get it on your skin. You do whatever it takes to make sure that you're not contaminated.
We want to make sure that nobody goes home in a condition in which they didn't come to work.
When we come out of that building, if we're all safe, then we've done a good job.
Before a building can come down, it's got to be ready to come down. And that can't happen without the skilled workforce that we have doing the pre-demolition work.
There's a lot of job satisfaction from knowing that I'm responsible for keeping any one particular or any crew safe so they can go home that day.
I think all the craft workers and all the management team as a team, we're taking a lot of pride in trying to do things and do things right so that, you know, we stay safe and we get the building down and continue doing our job here.
It's nice to know that we are part of that cleanup effort. And so it means a lot.
To be able to say, hey, I worked there, I operated that equipment, I helped tear it down, you know, that's a pretty good honor.
To the nameless warriors of building deactivation, we salute you. The deactivation team will release K-27 to the building demolition team in 2016. K-27 is the fifth and final gaseous diffusion building to be demolished at the Oak Ridge site.